We are in the middle of a full-blown AI revolution. I mean, businesses are plugging this tech into everything. But with this incredible new frontier comes a totally new kind of threat, one that doesn't use complicated code or malware, but just simple words to hack the entire system. And this is where we run into a really tricky and kind of fascinating new vulnerability called prompt injection.
You know, if you ask cybersecurity experts to rank the biggest risks for these large language models, or LLMs, this one thing, prompt injection, it consistently comes out on top. And yet, for so many of us, it's a completely new term. Think about that. The number one threat to the AI systems we're all starting to rely on is also one of the least understood. So here's our game plan for this explainer. We're going to pull back the curtain on this hidden threat. We'll start with why it's suddenly such a massive problem. Then we'll get into what this word hacking actually is, see some real-world examples of the damage it's causing, and really get why this matters so much. And of course, we'll finish up by looking at how we can even begin to build a defense.
Okay, so let's kick things off with a big question. Why is this suddenly a huge deal? I mean, why are we talking about this now? Well, it really just boils down to how fast and how deeply AI is being adopted everywhere.
Just think about it for a second. AI isn't some cool toy anymore, right? It's being wired right into the heart of how businesses run. We're talking about AIs that handle sensitive customer data, that help make critical internal decisions, and in some cases, can even take actions on our behalf. This deep integration is what's creating this massive, brand new surface for attacks.
And look, this isn't just some far-off theoretical fear. Get this. A recent survey found that a staggering 96% of business leaders believe that using generative AI makes a security breach more likely. They see the incredible potential, for sure, but they are also very aware of the risk. Okay, so we get it. The risk is real. But what is this attack, really? What do we actually mean when we say you can hack an AI with words?
At its heart, prompt injection is all about manipulation. An attacker writes up a special prompt, a bit of text, that basically tricks the AI. It's designed to convince the model to completely ignore its original programming, to forget all the rules its creators gave it, and instead to just follow a new, malicious set of instructions from the attacker.
You know, the best way to think about this, the analogy that security experts keep using, is that it's basically social engineering, but for an AI. You know how a con artist can talk a person into giving up a password just by saying the right things? Well, an attacker can do the same thing to an AI, tricking it into doing something it shouldn't, just by phrasing a prompt in a very clever way.
And this right here perfectly illustrates the core problem. A developer gives the AI its rulebook, its prime directive, right? Be helpful, stick to the facts. But then an attacker comes along and just slides in their own command, disguised as a normal question. But here's the kicker. To the AI, both of those things, they just look like text. They both look like instructions. The AI literally struggles to tell the difference between its original safe programming and a malicious command someone just typed in. And I want to be super clear here. This is not just a theory. This is not a lab experiment. This stuff is happening out in the real world, right now, to major AI systems, causing some pretty serious damage. Just look at this timeline. It's kind of crazy how fast this has escalated. In just about a year, we went from simple tricks that exposed an AI's secret rules, to hijacking bots to say horrible things, to actually generating malicious code. And then, we get a proof of concept for a self-spreading AI worm. The attacks are getting more sophisticated at a terrifying speed. Let's dig into one of the first big examples that really opened everyone's eyes. A student used this exact prompt on Microsoft's Bing chat. That's it. That's the whole hack. It's not complex code, it's just plain English telling the AI to forget its rules. And what happened? The AI just did it. No hesitation. It immediately leaked its own secret code name, Sydney, and then dumped its entire confidential rulebook for the whole world to read. It was this huge, embarrassing wake-up call that showed just how fragile these systems really were. Okay, but that was just the beginning. Things have gotten way more serious since then. In 2024, researchers showed us something they called an AI worm. Picture this. A malicious prompt is hidden inside an email. Your AI assistant reads that email to give you a summary, and in the process, it gets infected. The prompt then tricks your AI into forwarding that same infected email to everyone in your contact list. And the scariest part? It spreads all on its own. No one has to click a bad link or download a file. It's a terrifying glimpse into how these attacks could steal data on a massive scale automatically.
Okay, so we've seen the attacks. Let's zoom out a bit. What does all this actually mean for any organization that's using this tech? What are the real ripple effects here?
This is a pretty serious warning from the UK's National Cybersecurity Centre. Now, for anyone who's been in tech for a while, you've heard of SQL injection, right? It's been the boogeyman of web security for decades. Well, now the top experts are saying that this new AI thing, prompt injection, might actually be worse. So why?
Well, it goes back to that core problem we talked about. With older attacks, you could build clear walls between your code and the data a user gives you. But with these new AI models, the instructions are the data. It's all just words to the machine. And since the AI is designed to follow instructions it finds in text, it's incredibly hard to teach it which words are safe and which ones are a hidden attack.
And when you think about it, the fallout from a successful attack is just huge. You could have massive data breaches, leaking customer information or secret company documents. An attacker could hijack your AI to attack your other internal systems. You could suffer catastrophic brand damage from a public chatbot gone rogue. Or you could even get tricked into spreading dangerous misinformation, leading to all sorts of fines and legal trouble. The risks are just enormous.
All right, so this all sounds pretty bad, but it's not hopeless. So what can we actually do about it? How do you even start to build a defense against something like this?
Well, the first thing everyone needs to understand is that there is no single silver bullet here. There's no one magic patch you can install. Instead, the strategy is something called defense in depth. It's all about creating layers of security. The goal is that if an attacker somehow slips past one wall, they get caught by the next one. So, what do those layers look like in practice? Well, it breaks down into a few key steps. First, you harden your prompts. You use special formatting and very explicit rules to try and build a stronger wall between your instructions and whatever a user types in. Second, you use a classic security rule, least privilege. If your customer service bot doesn't need access to your financial database, don't give it access. Simple as that. Third, you have to monitor the AI's behavior. You log everything it does so you can spot weird things, like if it suddenly tries to download a huge file. And finally, and this one is probably the most important, you keep a human in the loop. For any really sensitive or high-stakes action, a real person has to give the final OK.
At the end of the day, you have to realize this isn't a set it and forget it kind of problem. This is a constant arms race. As attackers find clever new ways to trick these models, defenders have to invent new ways to protect them. Constant vigilance isn't just a recommendation, it's absolutely essential. And that really leaves us with this big final question, doesn't it? We're all in this race to make AI smarter, faster, more integrated into every corner of our lives. But are we putting that same energy, that same urgency, into figuring out how to secure it? Are we prepared to protect it, and by doing so, protect ourselves?